Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik, and in this lecture series on special theory of relativity, we are going to learn about relativistic momentum. Relativistic momentum and say total energy, how to deal with them. Now let's say, okay, we had derived for the expression of classic kinetic energy in the previous lecture, and that came out to be m naught c square divided by 1 minus v squared by c square minus m naught into c square, where this part was my rest mass energy, and I did not mention what this term was. Okay, let me show you today. The total energy that let me denote by E, that is equal to the kinetic energy plus the rest mass energy. That is the kinetic energy it is having plus the rest mass energy. Now if I add these two, it will come out to be, let me see what can be my E. E is equal to m naught c squared divided by root over of 1 minus v squared minus c square minus m naught c square. This is my kinetic energy plus m naught c square. So this m naught c square and m naught c square will cancel out. Then E will be m naught c square divided by 1 minus v squared by c square. This is my total energy. Now this total energy of this we have to relate with the momentum. What is momentum? Momentum is P is m v by root over of 1 minus v squared by c square. Okay, let's say in case of the classical physics, in the classical case, how we used to relate, we had kinetic energy expression that was very simple. K, that is half mv square. We could have written it very easily, half m square v squared by m, and m square v square, this term will be p square divided by 2m, where p is the momentum and k is the kinetic energy. Here the things are not that simple since mass is not constant. So let's see how can we write. P is equal to mv divided by 1 minus m is, let me write it m naught to specify rest mass, v squared by c square. This what we can write here, that okay, and E is equal to the total energy, that is mc square or m naught c square divided by root over of 1 minus v squared by c square. Now if I can take E square is equal to m naught square c to the power 4 divided by 1 minus v squared by c square. Now this c to the power 4, we will be writing it as just mathematical manipulation. I will take c square outside and I will write here the c square, v square minus v square plus c square. So this 0 I am resolving into v square and minus v square. Now let's see what I can write. This one 0 was v square and minus v square. Now this E square will be equal to m square c square v square, the first term, divided by 1 minus root over of v square minus c square, minus m square v squared into c square into v squared by root over of 1 minus v squared by c square, plus m square c to the power 4 by root over of 1 minus v squared by c square. Now this E square will be equal to, here just see here, this is m square v square divided by root over of 1 minus this root part will not be there, this root part, because I have already squared it. So m square c square v square by 1 minus v square by c square, m square c square v squared by 1 minus v squared by c square, and m square c to the power 4 by 1 minus v squared by c square. Now this one, what I can write here is that this will be mb root over of 1 minus v squared by c square whole square into c square plus, if I can take this part common, m square c square, I can take minus here, v squared minus c square. Now if I remove this, E square will be, this is P square momentum, P squared minus C square minus, let me take this common, this is C square minus V square, M square C square, V square minus C square. This 2 will cancel out and this will be plus, because C square minus V square and V square minus C square. So the final expression will come out to be E square will be P square C square plus m square c to the power 4. This is my total energy that is relating the linear momentum, that is E square will be P square C square plus m square into c to the power 4. So that's all for this lecture, and if you like our content then please subscribe to our channel and click on the bell icon.